Good afternoon. My name is Subel Schaffner, and I am the program manager for the Advanced Sensors and Instrumentation program under the Nuclear Energy Enabling Technologies cross-cutting area. And today I'm going to talk about my topic, which is under NEET 2 and the solicitation. First, I'm going to tell you a little bit about our program. The Advanced Sensor Instrumentation program vision is to develop advanced sensors and instrumentation to address critical technology gaps for monitoring and controlling advanced reactors. I don't know what's going on with this. And fuel cycle technologies. Our goal is to provide cross-cutting research that contributes to the success of the NE R&D programs by obtaining the needed INC technologies that support experiments, deliver unique sensors and related technologies for each reactor technology concept and fuel cycle facility. Also, research that enables the broader mission of the Office of Nuclear Energy by supporting common INC technology development objectives, and research that can overcome current barriers to nuclear energy system deployment. This includes research that resolves technology gaps, enhances functionality, and provides focused demonstration of advanced technologies to provide science-level evidence for acceptance. This program provides a new model of INC development, one that is more collaborative, coordinated, and designed to meet the needs of multiple programs. Okay, the research under the ASI program is divided in 4 areas. We have the advanced sensors to develop a fundamental understanding of sensors performance and to improve physical measurement accuracy and reduce uncertainty. The second area is digital monitoring and control to provide increases in control systems performance and self-calibration capabilities. The third area is nuclear plant communication to research and develop communication technologies needed to support greater data generation and transmission demand while maintaining reliability, resilience, and data security. And the last area is advanced concepts of operation to develop and test higher integral control system architectures where new human and system interaction is defined. Research in these areas need to support at least 2 of the DOE and R&D programs listed on the right. Last year we conducted a poll, and these research areas are still INC priorities for the programs. For this solicitation, we'll be requesting proposals under the nuclear plant communication area. Just to give you a little background or more information, we have 11 projects awarded, 3 in fiscal year 13, 6 in fiscal year 14, and 2 recently in last year. And for more information on all our research that's ongoing, you can visit our website and any website, nuclear.gov, and we have just recently published the 2015 NEET Cross-Cutting Award Summaries under the publications area, and we also have 2 newsletters on the ASI program, so that will give you a little bit more of information. So for our topic this year under NEET 2, it's advanced communication technology. We're looking for new technology that can get information transmitted inside a nuclear facility. There are a couple of challenges that you should address in your proposal to be responsive. The first one is you need to demonstrate that your technology has the capability to transmit greater amounts of data and signals through physical boundaries, such as vessels or containment walls inside a nuclear facility. Second one, with all the issues that we see today regarding cybersecurity, your technology needs to address the protection and integrity of the data and any other new communications demands. Just to clarify, we're not asking for cybersecurity research here, but for communication technology that takes into account the protection of the data. The third one is environment conditions during regular operation and accident scenarios need to be considered. Nuclear environments, as many of you know, have different conditions that are harsh to electronics, such as high temperature, radiation, vibration, etc. You need to identify the environment for your device that will work on and demonstrate its survivability and functionality for extended periods of time. Also, if your device will be able to continue to transmit data during an accident scenario, you need to account for beyond design basis situations. Um, and lastly, demonstrate that your technology will work for nuclear applications by testing it in a representative environment. We're looking for R&D that can be demonstrated and validated. Um, all these 4 bullets need to be addressed again in your proposal for consideration. And if any of them is not applicable to your particular proposal, I recommend that you address it by providing an explanation of why it's not applicable. One more final note. Since this is a cross-cutting program, we'll be looking for proposals that show how this research can benefit multiple reactors and fuel cycle applications. Here are some examples of outcomes that we're looking for. To overcome current limitation in today's wire system. Current state of nuclear plant is wired for data and have mostly analog sensors. We're looking for new ways to reduce costs and overcome current technology. There are new wireless technologies in the market, but you need to make sure that they will work in the nuclear environment and also be qualified for it and be accepted by the nuclear regulator. You need to understand the regulatory environment to get them qualified. We're also looking to reduce the wire on the power side by looking at new ways of power to power the communication devices. The next item is increased throughput of data. Look for ways to integrate the communication with instrumentation, information, and control systems and eliminate point source communication. Multiplex communication will be of interest. As nuclear facilities transition to a more digital environment, technologies need to support more advanced future digital architectures that are secure and seamless. For the last item, be environmentally compliant. Need to understand the environment where the technology will be applied. Be capable of meeting the requirements of electromagnetic interference and or radio frequency interference for sensitive nuclear applications to make sure that they don't interfere with the nuclear plant operations. And understand the harsh environment conditions typical of a nuclear plant environment. I mentioned that before. If it's going to be after an accident, you need to understand beyond design basis requirements. And summary, some of the expectations for this solicitation. As you plan for your proposal, I want to stress out that we're looking for advanced INC technologies that will aid in reactor and fuel cycle development, improve economics and safety, demonstration of proposed technology in a setting that represents the nuclear power industry, and innovative and revolutionary cross-cutting technology that can be applied to multiple reactor designs and fuel cycle concepts. I also want to point out that there is a topic under the NEET NSUF 2 that was presented yesterday that you can apply to if you need access to the nuclear science user facilities capabilities for your research. Please know that the research has to be already funded. This is just for access only. And lastly, here's our contact information. Bruce Halbert from the Idaho National Laboratory is the technical lead for my program, and he will be on the line to help answer technical questions.
Is it required to have an industry partner as a co-PI for NEET projects?
It is not required, but it's highly encouraged if you're going to try to find out what the final use of your technology will be. So.
Does fault-tolerant or resilient control fall into this work scope?
You had to, because we're focusing communication, you have to make the case how is it transmitting data or receiving data or reading data. So, Bruce, do you have any additional comments?
Yeah, the emphasis here is really on communications technologies, and if you're proposing new types of communications technologies that incorporate fault-tolerant and resilient controls into their design, then perhaps. But if you're just proposing fault-tolerant and resilient controls as part of controls technologies, then I would say that would be less relevant.
Are we looking for ways to improve the licensing process for INC upgrades?
I don't know if we're
That
looking.
would.
Okay, go ahead.
I'm sorry, Sue Bell. I would say that would definitely be a plus, but it's not mandatory at this time. I think we have to. I think the proposer should consider the fact that anything that they entertain is going to be applied to a nuclear environment. So it has to comply with existing requirements for nuclear applications eventually. How you get there, you have to think about that, especially when you think about the demonstration environment. So, the path to qualification may be something that's beyond the scope of the project.
Are you looking for a systems approach or novel device technologies?
Usually our emphasis on novel approaches, but we can consider system approach too.